Hi everybody, welcome to this next biology video. This is for section 10.1 in our textbook, and this is the introductory chapter to our study of evolution. So in class, in the past, we've talked about different kinds of living things, the different groups of living things, how we give living things names, and what exactly a species is. And scientists and even people just interested in the natural world a long time ago, say hundreds of years ago, were doing the same kind of learning. But then they started to realize that after documenting hundreds of thousands and even millions of different kinds of species that they were finding here on Earth, the question came to be, how did all these things get here? How did the Earth come to possess so many different kinds of species? And so there are lots of different theories for this, and we'll talk about just a few of these theories in this video. So let's get started with this creature right here. This is the star-nosed mole, and you gotta admit, this is kind of a weird-looking creature. This mammal digs in the ground and uses those feelers that's on its snout to actually find food while it's tunneling around in its underground colonies. You have to admit that if you were somebody who had never seen this creature before, and let's say this is hundreds of years ago, and you found this creature, you got to admit that this is kind of cool, and you'd probably ask yourself, how did this creature come to be? Was it designed this way? Are there moles without this kind of characteristic? And then why does this single species of mole have this characteristic? So that's when people started to think about how the species came to be on Earth. And there are many different theories for how organisms such as the star-nosed mole and all our other species came to be here on Earth. So let's talk briefly about some of those early theories. Remember, evolution is the biological change that happens to species over time. It's a process by which species descend from their ancestors. And we have evidence of these ancestors. For example, this fossilized creature here, the bones of which look a lot like modern-day horses, but not exactly like modern-day horses. And so this creature here that we have the fossil of doesn't exist anymore. It's now extinct. But we have remnants of this creature sort of evident in living creatures, living horses. So this is a horse ancestor dated to about 55 million years ago. It no longer lives, but somehow, perhaps, this creature transformed over a long period of time into the horses that we have now. Now, our modern-day horse is a species. And remember that a species is just a group of organisms that can reproduce and have fertile offspring. In other words, those offspring can also reproduce. That's the definition that we have currently for what a species is. But when we start talking about species in reference to fossils, things get a little bit more fuzzy. We can't apply this reproduction quality to fossils because, of course, fossils can't reproduce. So the whole species concept comes into question here as well. How do we know that this ancestor, this fossil that we found, is actually a species and is actually the kind of organism that came before any kind of organism that we have living today? So there are many scientists in the 1700s and in the 1800s that developed some hypotheses that later became pretty good theories on how evolution could happen. Carolus Linnaeus, our first scientist here, we've already talked about. He came up with the classification system of grouping and naming organisms. But as soon as he started to group them and name them, he realized that there were so many of them, and he started to think about evolution. And then there was this gentleman, George Louis Buffon, and he was a biologist, and he was one of the first scientists, first people to propose that there were ancestors of the current species that we have, and then of course there are the species that we have now, and that the species that we have now somehow, over long periods of time, descended from those ancestors that are now extinct. And he didn't have a way of explaining that, but he was one of the first people to explain that maybe that's how it happened. And then Erasmus Darwin, who was a family member of Charles Darwin, he was one of the first people to propose that more complex organisms or more complex species, again, somehow descended over time from less complex species. And that makes sense because a lot of the fossils we have of ancient creatures are relatively simple, and then the creatures we have now are relatively complex, although we do have some organisms now that are still relatively simple. So how come they haven't transformed over time? We don't really know why, or at least we don't have the complete story there. And then there was finally this gentleman, Jean-Baptiste de Lamarck, and he was the first to propose that perhaps the changing environments on Earth somehow influenced the traits that the organisms on Earth had. So as the environment or the climate changed, species would use certain adaptations or maybe not use certain adaptations that they had, and if they used them, they got stronger and bigger and they would develop in that way, and that if they didn't use that structure because the environment didn't require that they did, then they would somehow lose that structure. And one of the examples that Lamarck uses is with a giraffe, that if the giraffe were to stretch its neck to reach higher in the trees, it would develop a longer neck. He later realized that the giraffes were just getting longer necks because they were just growing bigger, because as a young giraffe grows into an adult giraffe, the neck just gets longer. So that was a good hypothesis, but not the best one. So before Charles Darwin could really synthesize all the knowledge that he had into our modern theory of evolution, he had to think about some things related to the geology of the Earth. And there were these three theories. The first one is catastrophism, and that has to do with the fact that some scientists believe that violent volcanic eruptions and earthquakes somehow split open the rock on the Earth and transformed it, and that's why we have the mountains and the valleys and things here on Earth, and that could only happen by some huge catastrophic event happening every now and then. We now know that those events do happen, but we know that all of the things that we see on the surface of the Earth, all the valleys and the mountains and things like that, are actually shaped in a slightly different way. The second theory is called gradualism, and we still partially accept this theory that things on Earth that we see have formed gradually over time. For example, the Grand Canyon, that wasn't formed by one gigantic earthquake that split open that canyon. We know that now. We know that the river that flows through the Grand Canyon eroded away that canyon, and that must have taken a long time. So it was a gradual process. And the last theory, which really is similar to gradualism, is called Uniformitarianism, and I know that's a mouthful. But what that means is that over the history of the Earth, all the things that have been shaping the Earth have been happening at the same pace. And if we accept that, or if that's our assumption, then we can actually work backwards in time. If we know how fast things are happening now, for example, the erosion of mountaintops, or the erosion or buildup of sediment at the bottom of a river or something like that, if we know how fast that's happening now, we can actually work backwards in time to actually see how long it actually took the Grand Canyon to actually form, and we reach the conclusion that it must have taken millions of years for that to happen. So all three of these theories are pretty good. Gradualism and uniformitarianism are really what fueled Darwin's theories about evolution. So Darwin really latched on to this theory of uniformitarianism, and that is that every layer of rock is formed by sediment laying down, time after time after time. And if the sediment on top is the youngest, then the sediment below it must be a little bit older, and then the one below that must be a little bit older than that, and so on and so forth. And if that's the case, the fossils that we find in those rock layers, we can actually put in chronological order. And that started the process of Darwin really putting together some fundamental pieces to his theory of evolution.